because I'm drawing a blank right now. Okay, I'm gonna take a picture of that and then I'll share my screen, and then we can see in detail. Okay, so I'm gonna share my screen. Okay, so this question?
Yes, sir.
Okay. Yes, I did cross. In a sense, in one sense, I did cross multiply. So our common denominator would be a plus b times a minus b, and so the 3 is missing the a minus b. So yes, I did multiply across there, and the 5 is missing the a plus b. So I did multiply across there. And it isn't traditionally what we would call a cross multiply, but I did multiply across the fraction. And then once I got that figured out, then distribute, combine like terms, and
yeah,
pretty much go from there. Okay. Do you have any? I don't know if anyone else has shown up yet. Do you have anything else?
And for number 11, wouldn't x plus y squared minus c squared, wouldn't that be the simplest form already simplified?
Well, okay, hold on, let me pull it up. So the question is actually asking just to factor it. So,
just to factor it.
Yeah, so it's not about being in the simplest form. It's demonstrating that you know how to factor.
Oh, that's right. I was getting it confused with the simplest form or the NR, and I thought that was part of the 7 through 10, but I see now it's factor form.
Yeah, and it's pretty clear on the test that, you know, if I just want you to factor, then stop there, and or you can at least come ask me. If you're not sure what the directions are saying, you're always welcome to clarify directions with me. So, anything else on the test?
Number 21.
The whole thing, okay? Let me make it bigger. Okay, which one in 21?
Number 21, C. No, wait, it's D.
C?
D.
Oh, D. Okay, so in that case, let me make a type in. Okay, so I'm looking at the denominators, and I have to find a common denominator between xy and x squared y. And so that's going to be x squared y. So it's at least got to have an x times x times y in it. And looking at that first fraction of 2y, what was it missing? Common. And it was missing the x, and then the 3 wasn't missing anything. So that we just carry the 3 over.
Oh, okay.
And then all I did was just simplify, just multiply the x and the y together. Okay. All right. Anything else?
That's it. But on your videos, you didn't simplify. I mean, you didn't have number 27 or 28.
Okay. If you, I had that someone point that out to me, and then I freaked out and went, "What?" And that is correct. They weren't there. They are there now. So if you go to your Blackboard and go straight back to where all those videos were, it's in there.
Oh, okay.
Not that you can't go there yourself, but let me just kind of show it to you. All right, so right at the bottom, I just added the link. I added it this afternoon. So if you looked the other time, then it wasn't. But it's there now. Okay. Anything else?
That's it.
Okay. Janet just showed up, so I'm gonna let I'll mute you and see if Janet has any questions. And so Janet, you can turn your mic on and ask away. Hopefully, you can turn your mic on.
Yes.
What would you like to talk about?
Number 27.
Oh, wow, that's echo right there. Not sure what's going on with that. You might have to mute it after you ask, I guess. I don't know. It's rather unusual that it does that. Okay. Oh, hey, 27. Okay, so this actually just got posted on Blackboard a couple hours ago. Let me, since we're all here, I might as well go through it now. So let me take a picture of it, and then I'll make it nice and big so we can see it. Okay. So let me start by saying that this question is not on the test. That's not the intention. But the test has word problems where you have to be creative and you have to come up with some sort of process to answer the question. So I just like this particular question, but you're not, like, I'm not going to switch the name to like Prince Alfredo or something, and that's not the intention here. So as I'm going through this, that's, don't need to freak out, hopefully. Okay, so the question is, this guy leaves the castle with a certain number of bags of gold. Every time he gets to a bridge, the guard asks for half plus 1, and he just hands it over and doesn't have any problem doing that, mathematically at least. So they're just not handing over like half a bag or something. And when he's done, he ends up having just 1 bag left after going to 4 bridges. So this is one of those problems that's a great idea to work backwards from. So if he ends up with 1, then let's go to bridge 4. At bridge 4, whatever the guy asks for, he hands him half of what he has plus 1, and he's got 1 left in his hand. Okay, so you have to kind of think to yourself, all right, what did he have? And it's like, if you think, well, what if he had 3? If he had 3, if he tries to give him half, he's going to have an odd number. That doesn't quite work. So there's got to be an even number here in order for him to give half. So if he gives 4, so if he has 4, half of that's 2 plus 1. So now he's handed over 3, but he's got 1 left, and that matches. So that means at the bridge he must have had 4 at the 4th bridge. And so sort of thinking of a process, how do we go from 1 to 4? Well, if we add 1 and then double it, we get 4. All right, so let's try that each time. So we're going to take the 4, add 1, that's where we get the 5, and then we're going to double the 5 and get 10. So at the 3rd bridge, you must have had 10. And repeat, add 1, and then double. So now we're at 22. Add 1, and double, and that puts us originally at 46. So he must have had 46 bags to start off with in order to do this particular pattern. So any other questions I can field about that one? I mean, you're not going to get that pattern, but you're going to get some pattern question that requires you to think and be creative. All right, I'm going to assume silence means we're good. So, yeah, if you think of anything else, let me know. I'm going to excuse myself real quick. I'm going to go get a drink. So if you guys come up with a question, I'll be right back in a second. Okay, I'm back. Janet, did you come up with anything else?
Yes, number 17.
17, okay. That is some impressive echo. Okay. All right, 17. Oh, the fraction one, okay. Let's see. Okay, so I'll make this nice and big. All right, so number 17, you've got 1/2 to the 6th divided by 1/2 squared. So this is a good sort of exponent rule type question. All right, so our exponent rule says that we can translate the exponent to each number inside the parentheses. So this becomes 1 to the 6th times 2 to the 6th. And then we have the divide rule that says if you're dividing by a fraction, you want to multiply by the reciprocal. So if I flip the 1/2 and that becomes 2 over 1. And then since they're both squared, I just carry that exponent into the numerator. Now, 1 to the 6th doesn't matter. It's 1 to the 6th is just 1 times 1 times, so that's just 1. 2 squared, so I've got 2 2's up top. And then 2 to the 6th tells me I've got 6 of them multiplied together. So only 2 sets of 2's will divide out, and I'm left with 4 2's in the denominator. So 2 to the 4th happens to be 16. So, yep, there you go. But so you're going to see some sort of fraction exponent combination. Anywho, anything else about that one? Okay. Do you have any more questions you want me to look at? Oh, okay, you got it. Okay, yeah. Sorry. Unless I go back to the... I'm not sharing my screen. I can't really see what people are typing. Well, I don't know. I don't necessarily want you two just to hang out. I mean, Liz says she got all her questions answered, and Janet said she's good. So, okay, or I could do 15A. That's fine. I'll go do that one. Okay, 15 in general, that's a good one just to take a second and talk about. A lot of times when students get this particular section on the test, they sort of misunderstand their goal. I get lots of, I'm going to prove it's true, and that's not really what it's asking for. It's asking for a counterexample. So your job is to try to find a way to make it be false. So with 15A, that's actually a true statement of absolute value. So that's good luck trying to find something you're not. But in order to test it, you want to try positive numbers, negative numbers. And what I was trying to show with that first part is I tried negatives, which is about the only time where maybe it's different. But because of the way the symbols are set up, even negative numbers still end up being positive. So there's no way for A to ever be, there's no counterexample that you can find. So that one would end up being true. But again, the goal is we assume they're all true unless there's evidence otherwise. And there wasn't any evidence with that particular one. So on the test, I'll give you a couple of algebraic statements like this. And you're supposed to figure out a number that would prove it wrong rather than find a situation that proves it right. So anyways, hopefully that helps. And let me go back to the main screen. Oh, 15B, okay. Okay, so in 15b, we're given this statement about a over b equals an over bm. So I get to, since both sides have a's and b's in them, it doesn't matter what value I pick for a and b. Obviously whatever I pick for a is going to be true on the left and the right. But m and n are not on the left. So that means I get to pick any number I want for n and m, and if obviously I could pick numbers where they match, but I'm looking for a counterexample. So I just picked two numbers that were different. Easiest two I can think of to work with are 1 and 2, and then I evaluated my expression. So up top here, if I have a times 1, I'm going to end up with just a, and then b times 2 gives me 2b. Well, obviously those are not the same fraction. A over b and a over 2b are two different fractions. So that means I found a counterexample, specifically when n equals 1 and m equals 2. But there's an infinite number of things. So I could have picked 5 and 23, and that still would have been false. So anyways, hopefully that helped. Okay, anything else you want to see? And if you guys have other questions outside the test, you're always welcome to ask those too. Number 19, okay? Oh, this is a good one. Oh, come on. Okay, so there's going to be some sort of statement where a student says something and you're going to have to understand the vocab and what the student's misunderstanding enough that you can provide some sort of justification for why it works or why it doesn't, for example. So this particular student says that she thinks subtraction of integers is commutative. So commutative means that I can switch the order around. So commutative means 2 plus 3 equals 3 plus 2. So when you're adding, the order doesn't matter. Multiplying, the order doesn't matter. So 2 times 3 equals 3 times 2. The student claims that that's true for subtraction. So she points out that in subtraction we convert it to addition. Therefore, it must be true. And so all you have to do to disprove that is just pick two numbers. I guess not any two numbers, but find two numbers where when I subtract, if I subtract in the wrong order, I get two different answers. So I picked 2 and 3. You could have picked anything you wanted, really. You could have picked 1 and 7 and whatever. There's a whole infinite number of choices there. But what I showed is I showed that if you take 2 minus 3, you get -1. And then if you switch the order, you get 3 minus 2, which is +1. So clearly, this is not commutative for subtraction. So there's my counterexample. And that's what I'm telling the student. Well, since it's not true for this set of numbers, it's not a rule. It might be true in a few cases, but it's not always true, so therefore we can't assume that it works that way. So like I said, you'll see some statement about a plus -b. Okay, let me read the question. A minus b equals a plus, so wouldn't a plus -b still be -1? Okay, so let me go back here. Alright. And, well, I don't think I need to write that. Okay, so let's do the translate part. So let's do 2 minus 3, which equals 2 plus a -3, which equals -1, right? But in order for it to be commutative, what the student is doing is they're saying, well, since 2 plus negative 3 is negative 1, then negative 3 plus 2, because addition's commutative, that also equals negative 1, so therefore that's evidence that I'm right. And that's not what commutative means. If it's truly commutative, then when I switch the order around, when I go 3 minus 2, that's the same as 3 plus negative 2, and I get a positive number. So the student misunderstood. So they said that this and this are equivalent simply because you can translate it into addition, but this statement and this statement are not the same. They don't mean the same thing. So that's all you had to do to have it show is just a situation where that doesn't work. If that makes sense. All right. All right. Let me see what people are saying. Or not saying. Okay. Janet, did that answer your question? Okay, great. What? Anything else I can answer? I had a face-to-face review earlier, and I had pretty decent size in there actually. So I think a lot of students that would have showed up to this kind of showed up to the face-to-face one. Anyways. Will 28 be on the tests? So the 28 about the college exam, that one. So the question itself is not, but the idea that it's a word problem and you have to translate what it's asking you to do, that part would. Since that was part of the two that didn't show up in my first set of videos, let me pull that one up and kind of talk through how to do it. It's actually not that bad a question. Okay, so 28 says on a college test, students receive 4 points for each question answered correctly, and a penalty of 7 points when the question is answered incorrectly. On this particular test, Terry answered 87 questions correctly and 46 incorrectly. What was Terry's score? So if you got 87 right, then I'm going to take the 87 times 4, and I'm going to subtract the number wrong, so it's 46 times 7. And I just type that in the calculator, and that gives them a score of 26 points. I don't know what the scale is for this test, so I don't know if that's, I mean, I would assume 26 is not a good score, but I don't know what grade he earned on that. So anyways, so that concept's not on the test, but reading and understanding and coming up with a solution is on the test. Anything else? Okay. I don't know. I mean, I'm assuming everyone that was going to show up showed up. So if I don't think anyone else is coming. So if you ladies don't have any questions, we can call it a night. Or I mean, like I said, if you guys have anything else about the class, any upcoming tests, or otherwise, we're just going to be staring at a blank screen for a while. Liz is out. All right. Janet, do you have any questions for me? Okay. Well, I mean, I can hang out and just stare at the screen, or if you're done, then you can just log out. And you can try talking. I mean, the echo thing, I mean, it's irritating, but that's okay. Sometimes it happens. All right. Well, I'm going to go ahead and call this a night.